Hi everyone, this is Professor Smith. This week we're going to learn about elasticity, which is simply a measure of how much one economic variable, usually it's going to be quantity demanded or quantity supplied, changes relative to a change in another economic variable. This has a lot of applications in firm pricing and also public policy as well. Let's take a look at the two demand curves that I have here on the left. Notice how in each of these two demand curves, the price increments are the same, $1, $2, or $3. Now take a look at the quantity demanded in this column here. It doesn't change much. The increments are just plus or minus 1. Now take a look at the demand curve here on the right. You have a big swing in quantity demanded. Think about, as an analogy here, a rubber band. If I can stretch the rubber band, we'd call it elastic. If I can't really stretch the rubber band, we'd call it inelastic. Now think about stretchiness of demand. I can really stretch the demand on the right. It goes from a very high number to a very low number. So the demand curve on the right is more quote unquote elastic than the demand curve on the left. Conceptually, just think about elasticity as a measure of price, of how responsive demand is to price. If you have elastic demand, like the demand curve on the right, you have very price sensitive customers. Okay, if you have demand like the demand curve on the left, you can see they're not very price sensitive. They're going to buy almost as much at $3 in this example as they do at $1. That's going to have a lot of implications for firm pricing. On the right are the demand curves that correspond with the numbers on the left. So these blue dots here are actually the demand curve for the one on the left. Remember, we put price on the vertical and quantity on the horizontal axis. So these blue dots are the inelastic demand curve on the left, and the orange dots, as you can see if I hover over the point, it will show you $102, $301. Okay, so the one on the right is the flatter, more elastic demand curve. All right, now let's dive into a little bit about how we measure it and then an application of why we care. So the formal way to think about elasticity of demand is it's the percent change in quantity demanded divided by the percent change in price. Literally just a ratio of those two numbers. Let's take a look at an example and then we're going to come back and categorize it using this little table I made right here. So let's suppose you run an ice cream cone business and you decide to raise the price of your cones from $2 each to $2.20, and you observe that the number of cones purchased falls from 10 to 8. We want to find the price elasticity of demand for this situation. So we're going to break it down into a numerator, which is the percent change in QD, and the denominator, which is the percent change in price. Now here's how you do a percent change. It's always going to be your final number minus your starting number divided by your starting number. So we started with 8 cones and started with 10 cones and ended up with 8. So your percent change formula is going to be 8 minus 10 divided by 10. This, by the way, is called the point method. That works out in this case to a quantity change of minus 20%. Okay, so again, putting this in context, that's going to be the numerator of our price elasticity of demand formula. So just simply store that number somewhere. This is how I do it. Now we need that denominator. The price went from $2 up to $2.20. Okay, so again, final number minus your initial number divided by your initial number. Okay, so the final number was $2.20 minus $2 divided by the starting price of $2 gives us a percent change of plus 10%. Now the formula tells you simply take a ratio of the two numbers. Now all I did here was I used Excel's absolute value function, which converts a negative number into a positive. And that's because sometimes you'll see elasticities quoted entirely as a positive number, and other times you see it kind of more correctly denoted as a negative number. Now let's learn how we interpret that. The absolute value is 2. Let me scroll back up to the interpretive table that I put together for everyone above. 2 would be in this row because 2 is greater than 1, but less than infinite. So I can see that my demand is elastic. That absolute value is greater than 1, so therefore the demand is elastic. If I had come out with a different example and I came out with 0.5, for example, that would be greater than 0 but less than 1, so that would be an example of inelastic. All right, let's practice with, let's take a look at an application first and then we'll practice a bit. Probably the single biggest application to business is elasticity helps you determine a firm's revenue and whether or not you should try to price your product higher or lower. Let's take a look at this example. Before the rise in price, the firm was earning $20 from these cones. $2 per ice cream cone times 10 sold is 20 bucks. After the firm raises price to $2.20 times 8 cones it's selling now, revenue actually fell to $18. Okay, so this firm actually lost revenue. Conceptually, what's happening there is that this firm is losing more in quantity sales than it's gaining in terms of the higher price per cone. Okay, so in this case, that pricing move might well have backfired in terms of this firm's revenue. And in fact, that's a rule of thumb to memorize. When demand is elastic, higher prices are actually going to reduce revenue, and lowering prices will increase revenue. So you're going to have an incentive to lower your prices. If demand is inelastic, it's going to be the reverse. Higher prices are going to increase revenue. Lower prices will decrease revenue. So in that scenario, you're always going to have an incentive to be constantly testing a slightly higher price. Okay, so elasticity is a huge part of firm pricing decisions. And as a rule of thumb, you go for the higher price when you have less elastic demand. And it's really all about this revenue effect. All right, let's practice with a couple of others. Okay, so let's say that you observe that a 5% drop in a good's price causes quantity demanded to rise by 3%. What is the price elasticity of demand? And is it elastic or inelastic? And if you were the firm running, if you were managing this product, should you raise or lower the price? Take a couple seconds on your own, pause the video if you need to, and I'm going to unhide the answer in just a few seconds here. Okay, so again, think about it on your own. I'm going to unhide it in 3, 2, 1. All right, so hopefully you came out with inelastic. Again, how did we get this? In this case, we have a 5% drop in the goods price. Okay. And actually I have my negative positive reversed here, so let me just make a quick tinker there. Okay, so that's going to be minus 5%. That's going to go in my denominator. A drop of 5% is minus 5%. Causes QD to rise, increase. So that's going to be plus 3%. So that goes in my numerator. Okay, so that ratio is minus 0.6. Or if I use the absolute value technique, 0.6. Since that's greater than 0, less than 1, you have inelastic demand. And if your boss says, I want to raise revenue, what should we do with the price? In this case, you're going to raise the price. okay, using the rule of thumb that we just learned about earlier, that loss of QD is going to be more than offset by the higher prices because of the inelastic demand among your consumers. Okay? All right, let's take a look at one more. All right, let's suppose price rises by 10%, QD falls by 15%. And again, let's answer what's the elasticity and should we raise or lower the price? So think about it on your own. And in about 10 seconds, I will unhide the answer. Okay, last chance to pause the video if you want to practice first. Unhiding the answer in 3, 2, 1. All right, so in this case, quantity demanded is falling by 15%. Okay, so again, that's going to be my numerator. And price is rising by 10%, that's going to be my denominator. Okay, so taking that ratio gives you 1.5. That's greater than 1. So in this case, demand, and that's actually already in absolute value terms. So in this case, demand is elastic. So if you wanted to pump your firm's revenue, in this case, you'd actually be tempted to lower your price. Okay, the demand sensitivity means you're going to gain more in unit sales, quantity sales, than you're losing in terms of the lower price. So your firm should go for a lower price. All right, the last thing I'm going to cover for our little mini video here is just conceptually, why are some goods more elastic than others? The key determinant of elasticity is the availability of substitutes. Okay, we learned about substitutes last chapter. The more substitutable products are available, the more elastic the demand is going to be, because then if your price rises, consumers can more easily switch to an alternative. Okay, let me give you guys a couple of examples. Which do you think is more elastic, wheat from a specific farmer or insulin? Think about it this way. Wheat is a pure commodity. It really doesn't matter if I buy it from one farmer or another. The product is perfectly substitutable across the farmers. Wheat is wheat. It's a commodity. Okay, that's going to be very highly elastic because all of that wheat is substitutable for other wheat farmers, from wheat from other farmers. Okay, not wheat as a product category necessarily. Let's take a look at insulin. Insulin's going to have very inelastic demand because people who need it to live are going to buy it at whatever amount they need to live, regardless of the price. They're going to pay that price. Okay, so in this case, wheat from a specific farmer is very elastic and the insulin is going to be very inelastic. Okay, so the wheat is more elastic. All right, let's take a look at the next one. Coca-Cola versus soda. Kind of tricky, but here's the answer. Coca-Cola is going to have a higher elasticity than soda in general, and that's because there are more substitutes for Coke. If Coke became really expensive overnight, I could maybe buy Pepsi. Yes, I know I probably have listeners thinking Pepsi and Coke are not the same, but they are somewhat substitutable within the same product category. If soda overall became more expensive, there are fewer substitutes for soda in general as a broad category than there are for a specific product within the category like Coca-Cola. So Coca-Cola is actually going to have the higher elasticity. All right, one more. DVD players measured over 6 months versus measured over 6 years. As a rule of thumb, measuring over a longer time frame is going to have a higher elasticity because the economy will come up with entirely new products that can make that product obsolete, like DVD players. All right, measured over a 6-month period of time, consumers are going to be less likely to be able to substitute away from that particular product, from their DVD player. So in this case, the higher elasticity is going to occur over the 6-year period.